Good evening, everybody. My name is Susan. I'm an enrollment coordinator on behalf of George Mason, and we're here tonight for the online Masters of Data Analytics of Engineering, along with the graduate certificate. We're joined here with the program director and assistant program director and academic advisor for the program. And so they're here to answer all your questions. The agenda for this evening is to meet our wonderful presenters and why should you do this program? The driving forces behind data analytics, details on the curriculum, industry trends, the online classroom, and of course, admissions requirements and Q&A. And feel free to post your questions in the Q&A session throughout or through the chat. We won't be really raising our hand here, but through the Q&A. And without further ado, Dr. Baldo, would you like to kick us off?
Sure. Well, first, I'd like to welcome all of our attendees here this evening. Thank you for coming on to get some insights into our program, Data Analytics Engineering. A little bit about myself. I have about 40 plus years of industry experience before I became a full-time associate professor at George Mason University. I was an adjunct professor here for about 19 years as well. I recently moved the program down to Mason Square. So I just wanted, because if I forget to tell you that, that is part of the background here. So the program now is down in the Arlington campus in the new Fuse building that we have there. So I worked in industry. I spent 15 years at Oracle. I've spent a number of years supporting commercial industry, government, and defense. So I have a diverse background with respect to software and data analytics. I still practicing engineer. My experience base right now as director of the program is primarily focused. I spend most of my time these days with data, handling data. Still do analytics, no question about that. But data has been the key focus, and we'll talk a little bit more about that as we go further. I have a PhD from George Mason University. It's in information technology. I have a master's in engineering and computer engineering from the University of South Florida. And I have a master's and an undergraduate degree in chemistry. So my pathway is in some cases similar to a number of the students that are in this program. Not all of our students come from engineering backgrounds. Not all come from computer science backgrounds. Some come from math, chemistry, biology. We have folks that come in with business or accounting type degrees as well. So that is the interesting aspect of data analytics engineering or analytics in general, is that there comes in with people with diverse backgrounds. With that, I'll turn it over to my great assistant director, Professor Vernie Schmidt.
Thank you, Dr. Baldo. Like Dr. Baldo, I have a background in industry. I have had over 35 years in industry before becoming an academic myself. 15 years ago, started as a professor of IT at Northern Virginia Community College, joined George Mason 5 years ago. All my degrees are from Mason. I have an undergraduate in computer science, master's in applied IT, and a master's in data analytics engineering. I was actually one of the first students in the program when it first started. Graduated from the program in 2017 and was recruited by Dr. Baldo in 2020 to be his assistant director. I'm also the capstone coordinator. So after you've completed the 9 courses in your program. The 10th course is the capstone. And when you get angry at me, angry at all the work you have to do in the capstone, you can blame me for that. The idea behind the capstone course is to prepare students for real world. It's a capstone course. That is unlike any other at the university. I solicit real world data analytics projects from a number of capstone partners. Last spring, we had 40 capstone projects. This fall, we have 24. We'll have another 24 this spring. And our partners range anywhere from Pearman Cellars Winery in Northern Virginia to uh, um, two of our partners are based out of Europe. Erasmus.ai that developed Climate GPT is one of our partners, as is GaiaViz, who is based outside of Paris, France. So we have a variety of partners, both industry, academic, as well as nonprofit that we work with. But the whole idea behind the capstone course is that you work on a real world data analytics project. It's very labor intensive. It's almost like a part-time job in that sense. But you gain a lot of valuable experience as taking part of that. So I'll turn it over to you, Mary, then, is our third person here.
Yeah, hi everybody. I'm Mary Baldwin Sloop. I'm the graduate academic advisor for the Data Analytics Engineering Masters and the Data Analytics Certificate. Just so you know, I actually come more from a social sciences background. My graduate degree is in linguistics, so language data, NLP, computational linguistics. That's kind of my jam, the thing I love talking about. And I've been professionally working in student support for over a decade now, and have been working with this program for quite a while. And so I love working with students from all different backgrounds to kind of explore the diverse opportunities that are available within this program. And I'm kind of the person you go to when you're like, I have no idea who to ask this question. You ask me that question, and I help you get an answer.
So in terms of rankings, we have made it up to the in 2023 we did make it in the top 50 with online master's engineering programs in U.S. News and World Report. That was quite an accomplishment. One of the things that I would like to let you know is that when Professor Schmidt said he was one of the first students in the program, the program started back in 2014, and we celebrated last fall our 10-year anniversary as a program. And so we've been getting a lot of we're getting a lot of notice, but this one was really great to be rated this high on the U.S. News and World Report. The way we have things structured, as Professor Schmidt was mentioning, we're a multidisciplinary program, and this was a big push from the dean of the college, Dr. Ken Ball. We have since, around 2019, we became the College of Engineering and Computing, and then we broke up into two schools, School of Engineering and the School of Computing. This program is in the School of Engineering because we are very focused on performing engineering type activities. But because we're multidisciplinary, we cut across both schools, all the departments. We cut across all the departments. So we have a very, very rich number of our course offering is very diverse, very large. We have over 100 courses to select from. Now, I do want to, because Mary will shout out here in a minute, we don't have 100 courses to offer on the online program. And the reason for that is that the online program is asynchronous, and courses have to be transformed into an asynchronous format, as well as they are in session-based 8-week sessions, and they have to be condensed to fit into the time frame and into the fact that they're asynchronous. But we do have a number of courses to offer online. And we also go outside of the College of Engineering and Computing. We have course offerings from the business school, from our College of Health and Policy. And we continue to look for finding other areas where we can work with other colleges and schools within the university. So it continues to evolve. And I think one of the things that you have to keep in mind with our program is that it is extremely diverse and that you can tailor your needs. You can tailor your needs to quite a few things. I mean, so it's extremely broad, and so it's flexible for the student. Um, the other aspect here too, that was touched on earlier was that because we cut across all these schools, we have access to a large number of world-class researchers within George Mason University. George Mason is the largest public university in Virginia. And we've attracted some great faculty um, in the past, and they're still here with us. And so that's a great advantage to learn from some of the best folks in their fields. A number of the faculty, as Professor Schmidt had noted, including both Professor Schmidt and myself, we have industry experience. The other thing that we have here is our research centers on campus. Within the college, we have a number of research centers that actually work with industry and government. They actually go off and compete for contracts. And there are cases when we get pulled in to work on those as well. So the faculty are not just folks doing basic research. In fact, Professor Schmidt and I are applied researchers. So I think that's an important thing to note when you consider us for a program. The online program also offers a graduate certificate option. Certificates, and this certificate is also under the umbrella. Our program is SHIV approved, so that's a big plus for us, or for anyone getting a degree. That certificate is also under that umbrella of being SHIV approved. So we've had a number of students who they want to come in, they want to take the 4 foundation courses, which is all the 4 courses you have to take for the certificate. And that's good enough. They just wanted to get some background, so they took the time to take the 4 courses, which you could do in 2 semesters. But there's always the option that if you want to pursue the degree, those 4 courses count. And you just move on. You register for the degree program. You talk to Mary, and she'll work out a schedule for you, and then you can continue to move through. I think that that type of a certificate is extremely valuable, and it also can be acquired in a short period of time. So in some cases, people have found it as a career advantage because on their resume, they're able to put the certificate on. And also some people use it that they're not quite sure exactly what they want to do. So, hey, they go after the certificate, and after they take the 4 courses, they can make the decision of, hey, I think the program's for me, or no, I think I have enough, and this is good enough, but no pressure whatsoever. So it's a nice option to have.
We did talk a little bit about the program being established earlier on. Obviously, data is proliferating in so many venues. It needs to be analyzed. It can be used for so many goods. And our program is very broad. So when we talk about the kind of places that our students go, it could be in healthcare, it could be in finance, you could be working for a tech company. And data is kind of undergirding everything. So it was created, and Bernie and Dr. Baldo and Professor Schmidt can kind of expand on those goals, those professional goals. But there is a growing need right now to be able to take all of these massive data sets to make them useful for business decisions, for medical decisions, for risk assessments, for improving supply chains. And so that's why the program was designed to be interdisciplinary. That's why it was designed to be flexible. That's why we've tried to make it accessible, even if you are in Ghana or if you are not physically able to come to campus, because we need data analytics engineering professionals in this growing field. We've been working to implement and bring in more courses in deep learning, NLP, AI, the kind of modeling classes that are really undergirding a lot of this work right now into the online program. We were talking about how there's fewer courses than like the full 100 plus on the on-campus. But I do think that we've worked to get some of the most popular and most in-demand classes transferred to this online format to make it accessible. And in terms of industry trends, again, I think Dr. Baldo and Professor Schmidt will be able to speak on this a bit more, but it's one of those things that's constantly evolving, and that's why, as Dr. Baldo said, we're constantly adding more courses, we're diversifying, we're connecting with other departments, which means connecting with other skill sets so that students can become blended engineers in this program and go out into a variety of fields. And job growth, specifically, I think, Dr. Baldo, when we were talking last, was it systems operations kind of positions that were growing a lot? You showed me some stats recently. I think that's what I was noting.
Yeah. And so the reason the three of us will talk to this slide here is that when you come in contact with the advisors, such as like Mary, most people will talk about, well, they'll ask Mary or they'll ask Professor Schmidt or myself, what's the outlook from a job perspective, or what does this program offer that other programs don't? And I'll say a few words on that, but I wanted to have Professor Schmidt weigh in because he actually went through this program early on, and there was a reason why he decided to go after this. It wasn't just that, hey, I'm collecting degrees that I want to put on my wall. There was a real reason as to why he was interested in doing this. So I'm going to let him sort of give that, and this is all part of the driving forces.
Thank you, Dr. Baldo. Yeah, it's interesting. I never actually was going after this degree. I already was a professor at Northern Virginia Community College, but one of the adjunct instructors who actually teaches in our program right now as well was teaching the first AIT 580 course, which was the introductory course you take, and he invited me to participate in the course. He was doing data analytics for a three-letter intelligence agency and couldn't tell me much about it. He was an instructor in my first master's program, the Applied IT, so he invited me to attend, and it was very fascinating. I found the AIT 580 course back then absolutely fascinating, and I was just going to take another couple of courses just to see what it was all about. And next thing I know, I'm 6 courses into a 10-course program and had to decide to actually enroll in the program. I don't recommend you wait that long. You're supposed to enroll after 4 courses as a non-degree student. But the whole concept of data and data science resonated with me. In fact, there was a Harvard Business Review back in, I think, 2012, said that data science was the sexiest job that was out there, and it's only grown. Dr. Baldo and Mary mentioned about artificial intelligence. When I was in the program, we were not permitted to take any AI courses because they were only offered out of the computer science program, and they were restricted to computer science graduate and PhD students. Since that time, the applied IT program has created their own applied artificial intelligence courses, which our students can enroll in the online program. But even more so, the capstone course is very much an applied course, and that is where we are unique in the university. In the last, when large language models hit the scene a couple of years ago, ChatGPT, Microsoft Copilot, Claude, Anthropic Claude, Meta Llama, they were a novelty at first, but then they started getting integrated into day-to-day operations. And that's kind of where we are today. Out of the 24 capstone projects we have this semester, about half of them deal with artificial intelligence in some way. In fact, there are at least 5 capstones teams, 5 capstone teams that are actually working with large language models right now. We have 4 teams working with Erasmus AI, who, as I said, is the creator of Climate GPT, and Dr. Baldo is working with a team with another company, capstone company, that's involved in that as well. In fact, actually, there's another one I just thought about is one of my teams is using a large language model to try to match resumes to job postings to enhance a job seeker's chances of matching uh, uh, more appropriate jobs from, say, from a job bank. So it's become a very, very uh, hot area to study, and you're not going to find courses typically in most universities that are even teaching those concepts. It's so still new. And yet we're able to incorporate them into our capstones, and that's invaluable from my perspective as well as Dr. Baldo's perspective. In fact, Dr. Baldo is a driving force for having for working with me to include these new types of capstone projects into our curriculum. He's been very supportive of that effort. So, and that maybe you want to add on to that, Dr. Baldo, as well.
Yeah. So I wanted to ask to have you understand Professor Schmidt's motivation to go into the program, and his is not uncommon. Okay, people have an interest, and also I wanted to have Mary say a few things as well, because Mary will pick up on these sort of things, and that's important for her to understand that as an advisor, to sort of help you make decisions on that big number of courses that you're going to select from. So want to thank both of them for saying that. I'll talk about the industry trends when I get my industry trends when I get to my slides. Professor Schmidt provided some what he said is spot on. I mean, we cannot ignore these emerging technologies that are moving so fast. But I do want to talk about the background for the program and why it was created. When it was created, when the idea came up, the original director, Bob Osgood, sort of laid out this plan where he wanted to make this. There are other data analytics programs across the country that are specialized, like in business, healthcare, social sciences. But he was thinking to make a unique program that was for the generalist, the general data analytics engineering. And we put engineering on the end of that because we do deal with data, we do deal with analytics, and we do deal with the visualization or producing the results that come out of our analytics. But we also, underneath all of this, we do some engineering. We have to worry about some of the things that Professor Schmidt was talking about. And when you talk to the advisor, when you talk to Mary, there are certain courses that we take that are very much engineering based. So the idea was to create a very unique program. And as of today, I mean, when this program started about 11 years ago, there's not really, I have been unable to find a program that's similar, data analytics engineering, that is a general, broad spread, multidisciplinary, broad spread program. So I think that is a really, really big advantage. It is not to say that, hey, you shouldn't pick a program that does finance. You shouldn't pick, or one that specializes in healthcare. Those are good. But the generalist, and it's not a generalist because you don't know exactly what you want to do. As a generalist, as Professor Schmidt had mentioned, there's lots of different areas that you can practice in. So you could be on a team, and most data analytics engineering is team-based. So you could be on a team, you could be on a couple of teams at one time, because when I practice, I am sometimes on a couple of teams. So you could be doing some healthcare analytics, you could be doing some financial analytics, you could be working in some very, very specialized domain that's somewhat limited, but you can go off and apply those general skills that you get from this program here. So that was why it was created. And the background there was the need to produce the generalist data analytics engineer. So the question, is there a need for this program today in today's society? Absolutely. When I consult around the Washington, D.C. area, I'm sometimes on teams with my former students, which I just find I'm ecstatic about that. And the need is the generalist can view the broad spectrum of things that have to go on when you're performing data analytics. Okay, so you can get involved with deploying the analytic. You could get involved with the actual tuning of a model. And as Professor Schmidt was talking about, you could get involved with coming up with innovative ways to use new emerging technologies like LLMs. So you can be very, very flexible. And lastly, what I will say is that with most engineering domains, and this one is no different, we are all lifelong learners. Um, Professor Schmidt sort of hinted about that when he started in the program. The classes were focused in with technologies that were there. And now over the years, over this decade of being in existence, the university has also adapted new technologies into the program, as well as new analytics that may have emerged or new visualization techniques that have emerged. Um, Professor Schmidt had mentioned that in one of the capstones, he mentioned that he has a partner called Gaiavez, which is just outside of Paris. They do 3D visualization on a 2D platform. So basically it looks sort of like a game engine where you can plot your data under this 3D space and you can move around. You can actually walk through the data. You can look at it from the top, from the bottom, from the sides. You can slice things with it. It's extremely cool. In fact, I was 3 or 4 years ago, I wanted to take the Unity game engine and use that to walk through my data. And here they had already built this. So it's been really, really great to have a tool that's there that you don't have to spend 2 years or 3 years trying to build out. It's there. Okay, Susan, I guess we better start to move here. Okay. And Mary, I'll let you
I'll
talk to
just
this one.
quickly go over. So in terms of the curriculum, it's a 10-course program for the masters. 5 of those courses are our core courses. 4 of them you'll do at the beginning, AIT 580, CS 504, OR 531, and STAT 515. That is your interdisciplinary introduction to different aspects of the field, from modeling and visualization to data mining, some cloud computing, all kinds of good stuff. The capstone is DAEN 690. That is the thing you do at the end. That's that real world project that builds on all the information that you get through the rest of your time. And I think the next slide has our concentration information, right? All right. So those 5 classes are your core interdisciplinary study in your capstone. 5 of your courses will be your concentration. Now, in the fully online program, these are currently all the classes we have available. And so you can't do, we have 14 full concentrations on ground, but most of our students do an individualized path of study in the fully online program, just because it gives you the most flexibility. Like we were talking about, flexibility, that's the key word for this program, to pick and choose classes that will give you skill sets that are going to be useful for you in your particular career path. It is possible to do either our applied analytics concentration, which would consist of classes from those IST electives you see over there, or potentially the business analytics as well. That is another potential option. But most of my students do find they get the most in the online program by doing the individualized path of study. And you would work in consultation with, you get 2 supports in the online program. You get a success coach and you have your advisor, which is me. And we would work together each term to kind of figure out what classes that are being offered fit your needs best. And that can range from marketing research to digital forensics, so stuff on cybercrime and networking data, to issues of LLMs or even decision and risk analysis. But yeah, lots of options that you can kind of leverage throughout your time. I think we can go on to the next one.
This is some trends that I just want to briefly go over for you. So about 3 years ago, there became a shift in terms of we were centralizing our data as back is, I would say now 15 years ago when we started to migrate a lot of applications to the cloud enabled us to, with cheap storage, and enabled us in centralization for access to put a lot of data into the cloud and make it accessible. So it was cheap. We didn't have to have, a business didn't have to have a closet with a server in it and a bank of drives and things like that. Which was difficult. I mean, they had to upgrade, things would go wrong. You had to have an admin, things would break in the middle of the night. Somebody would have to come in or log in and try and fix things. Or worse yet, if they couldn't get in, they'd have to drive in. So with that movement, we started to create things that they call this data lake. And the data lakes were great, but they were also messy and they became very, very difficult. So then we started to see these things called data lake houses. And eventually what happened is people wanted to see something that they could consume, but didn't have to go into the data lake or the data lake house to pull all that data out every time they wanted to do a project. So we started to build what were called data products. And this is still ongoing. Okay. And Professor Schmidt and I are doing work in this area. In fact, I have a student in the program who I did some research, he's since graduated, did some research with in the fall of 2024 through our DAEN 698 course that was there that Mary had up. That's a research course that you can take from 1 to 3 credit hours. But we did some work with data products for a particular domain that he's involved with, and we have a follow-on contract to actually do some more work with him. But this data product is sort of interesting in the sense is that it can be defined, so there'll be a specification for it, and there'll also be a contract for it as well. And it has metadata that surrounds it, so it says this is what it can do. It has a quality infused into it. It also has some hooks in there for governance, so the privacy, the access controls. And one of the really interesting things about this is that it's built and it can be static or it can be dynamic. So static is what you might be used to. You might say, hey, Jim, I already have these CSV or these Excel spreadsheets. Are those data products? And I could say, yeah, they are. You probably store them on your file system locally, or they sit central someplace. But data products also they're attached to a catalog or they're referenced from a catalog. So they're searchable. Okay. And also they can be dynamic as well. So you could have something, you could have a data product that actually refreshes itself on a regular basis. Okay, so they could be sitting there connected to the data, and it might, in its contract, it says it refreshes itself every 15 minutes or so, or every 15 milliseconds, depending on what the refresh is going to be, what is needed from a refresh perspective. So like something like Apache Iceberg, if you're, that is used as a materialized view to keep that product up to date. But the end user doesn't have to worry about building that out. The producers of the product do that. Okay, and so then somebody comes in, and a data scientist, somebody who does analytics, there's AI/ML. There could be it could be an agent that comes in that wants to use it, or an LLM wants to use it. So this is a trend that we see. It makes a lot of sense. It is evolving. One of the things with that contract is that contract from the specification is usually written in something like what's called a YAML file, and that's executable. It could be executable, which means that somebody could write a specification, have it mapped to a contract, push the button, and an application would actually build the data product on demand. So That's some of the basic applied research that we're trying to do with our data products that we're looking at for this particular domain. Okay, can we go to the next slide? And so where does all this sit? I'm showing you an example of data mesh architecture, but I don't want to, I want to state up front that these architectures, regardless of what they're called, have different names. This one particular data mesh architecture is an abstraction. So you can read about it and then you build it out based on your needs. But the key ideas, the big idea here, if you unpack this ton of stuff that's in the abstraction, is that you have the data product that's in the center. And there are end users who are going to be using that data product. And in order, you're going to have a platform, and this architecture will be realized with a platform that will perform the governance. So that takes care of all of your privacy, your compliance, your access controls and whatnot. And that's handled in the platform automatically. And then you have this data platform team that performs things like the data ops on it. It makes sure that the data product itself is in the catalog so it can be discovered. So an end user comes in and they're looking for something specific and they type in, hey, this is what I'm interested in. It could be a keyword search or it could be front-ended by a chatbot or something like that. There's all sorts of options. And all the storage and the querying and all that is all taken care of down at this platform. So we really see this as the trend is seeing the data products, and then this is where the data products are going to sit. Now, they could be a different architectures, there's no question about that. But clearly this is happening. And why is that? Because data continues to grow at exponential rates. And in order to make data accessible across various different problem spaces, you really need to sort of catalog it, make sure that people understand it. You have some type of a specification that helps you understand what this is. Because in one domain, this data product could be in high demand and it could be of high quality, but in another domain, because maybe of its update rate or maybe because of the precision of some of the the type of data that's in there, it could be of low quality, but still usable and accessible. Okay, we'll go to the last slide here. And the question came up was, how are data analytics engineers using AI? And I want to sort of extend this a little bit in a different way than and expand upon what Professor Schmidt was trying to summarize earlier. What we're seeing here in a trend in data analytics engineering is that AI is being applied, and this is at a very, very high level. So this is the way that one particular view of it. We see AI being applied in the data pillar, or the oval here, the intelligence oval, the orchestration oval, and the delivery oval. And let me just say a little bit about all those. So data, relational databases aren't going away, nor are data warehouses, nor are object stores. All of those things are going to be available. So data is placed into those source systems, and how they're placed in there, how schemas get generated, are there ontologies that need to go with it? Is it a graph database? Is it a vector database? Is it a NoSQL database? There are various design tools that help you out with what is the best way to store this, okay? Then the notion of catalogs and governance is critical. Governance requires policy. Policy has to be translated into something that is understandable by a machine or by a human being. And then you have to have enforcement mechanisms that are there. So that is all part of this AI wave that's coming in, as well as with the catalogs. Understanding those policies, lineage is important, the pedigree of the data, all those things are critical. And then the data platforms that process this data. So we take some of this raw data. We are trying to do this intelligently now. In some cases, where before we would have a standard flow where we would be doing this Python programs, for example, or C++ programs and processing data. In some cases now, we might be able to stick an LLM in there to do some of this processing for us. Maybe not all of it, but some of it. Um, and of course, it depends. I mean, in some cases, there's privacy concerns, so we don't want to use a commercial LLM. We want to use a local LLM, and all those things have to come into play. From an intelligence perspective with our analytics, as Professor Schmidt had noted, we are using LLMs. There is no question about that. And it's sort of interesting because Professor Schmidt and I, in a lot of cases, when we're working with teams and you're using an LLM, the prompt is really critical. And just 12 months ago, we're still talking about prompt engineering. And today that's prompt engineering isn't the appropriate term because doesn't really match what just the prompt is. So now we're talking about context engineering. The prompt is still there. We may have to make some changes to that, but the data that we might include in there is important. If we include things like evaluation criteria, that's important. So now we're looking at context engineering. And then retrieval augmented generation, RAG, that is still a very, very important aspect. 12 months ago, I would say that we were seeing lots and lots of papers on this produced on a monthly basis. It's waned a little bit, and the only reason for that is that other things have caught the attention of this very, very rapidly moving wave. Agentic systems are clearly on the landscape today. People are using them. And in our capstones today, one capstone partner one of our capstone partners that Professor Schmidt referenced, we have 4 project teams that are working on this, and what we're doing is that their particular LLM that they built needs to use external data to answer prompts that come from their customers. And so we're using the message context protocol, MCP, as a facade that's used so that the LLM can look and see what sort of particular types of, in this case here, data, but the tools that it has to offer, or the resources or the prompts. And then it makes a decision on whether it wants to use some of those tools or some of those resources to help it generate a response back to a prompt that it received from its front end. So those are very, very important. Clearly, your knowledge of SQL is important. Knowledge of a programming language like Python. We have some people that are using Rust because of its performance capabilities. And then, of course, not to forget, safety evaluation and guardrails are really, really important. I want to go on to the orchestration because this is one area that is really significant and continues to be very important. When I was mentioning that those data products can get updated, you have to be able to allow that to occur, but also as you're processing new information is coming in, you have to be able to connect the dots, get that data in there, process it. So things like Apache Airflow are important. Continuous integration, continuous development, that's not just for software development, software engineering, that's important for data analytics engineering. So, and Professor Schmidt has a lot of good experience in that type of work. This notion of, X ops, or so you have mil ops, and now we have LLM ops, we have data ops, monitoring that data. We're monitoring the analytics that we have, looking for things like drift is very, very important. And then risk and compliance is crucial, especially when something goes into production. And that compliance, especially like if you're in healthcare or in a lot of things where you have to protect, there's privacy laws. I mean, laws, they could be local laws, they could be state laws, they could be at the federal level or across countries. Okay. Then we get to the delivery piece, and this is where it gets really, really interesting. So that end user needs something. And it could be just, they need an auto-gen report that they're going to read, or they need some sort of a dynamic visualization that they want to go off and explore with to try to acquire insights that might help them initiate some actionable things. So I'm gonna stop there. And the emphasis here that I was talking about is that AI is crucial to data analytics today, especially data analytics engineers. And as Professor Schmidt was noting, we are using that. LLMs and agents are certainly two key things that we're engaged with today, but there will be others as this thing moves along. So with that, I think, Susan, we've maybe reached the end here.
If
Okay,
you
go
if you
ahead.
want, Susan, do you want me to speak to the slide real quick? I know we're almost out of time. Or
Sure,
Yeah.
go ahead, Mary.
yeah. So just basically in the online program, your courses primarily are going to be 8 weeks asynchronous. You're going to have an online learning platform where there are going to be recorded lectures. You'll be interacting with your materials through Canvas. And the only class that you're going to have that's going to be slightly different is that capstone. That's going to be online, but synchronous. It's going to last the full semester. I know someone in the Q&A asked about that. And so I did want to clarify most classes asynchronous and, working through those modules. But your final course will be synchronous with your class, your team, and your professor, but in an online format. And if you have more questions about details about that, please email me after the meeting so I can answer those questions in more depth.
Perfect, thank you.
Mhm.
I have a quick question. So being that it is online, what kind of interaction would you expect? Like if you had any, questions regarding the assignments, how does that work?
Sure, so I can talk to that. So I actually have created one of the foundation courses that Mary was showing, the CS 504, data management and mining. So I created the online course, and how that works, Susan, it's a great question. It's supposed to be asynchronous. So on one hand, Susan, if you were a student and I don't need to talk to the professor, I'm going to just, the lectures, a lot of the lectures are videos by me or by other professors. And then there might be some reading, but there'll be assignments, quizzes. All that is, and even projects, the CS 504 is project based. Students work in teams, but the professor doesn't have to be engaged at all. Now, on the flip side of that, if you want to work with the professor or you have a question, you can reach out to the professor. We do everything in Canvas, so you could send me a note. One of the things Professor Schmidt instituted for all of our courses, including our online, was we created an MS Teams channel for the course, and you can do chats in there and communication and virtual sessions. So I have a lot of students in the course that say, "Hey, we have a virtual session? There's a particular problem I'm having with the assignment," and so we go into MS Teams. The student shares out their screen. We look at it. We talk about it. And try to solve the problem or answer the question that the student has. A lot of back and forth with email. And sometimes if that if the number of emails starts continuing, it gets really, really large, I just say, hey, let's just have a meeting like this and let's talk through it to save you some time. But that is sort of those are the options. So that in one extreme, you don't have to you don't ever have to talk to the professor at all. The other extreme is you can communicate as much as you'd like with the online instructor. Some of the instructors, including me, if I have a large course, I might have a grader that might grade some of the homework. Um, but for smaller courses, uh, like less than 20 or so, then usually the instructor does all the grading and all the interaction through the instructor.
That's
But thanks for that. That
wonderful.
was a good question. Hopefully that answers some questions out there in our audience.
It does indeed. And how long would you say that you have to devote to each class per week, would you say?
So I'm going to say something, then I'll let Professor Schmidt and Mary chime in as well. When we set the course up, when we set the online courses up, there was an estimate that we were given from Carnegie Mellon on online, and for our courses, and they used some type of a formula. It was anywhere from it could be anywhere from 10 to 15 hours per week. Now, that might vary a little bit depending on, we have like 8 modules. That might vary a little bit across the modules, and it depends on the course. It also depends maybe if one course is a little more difficult for a student versus another one, it might take a little more time. But that's okay. I mean, there's the enjoyment of mastering the material and learning it, so it's worthwhile. But normally between 10 and 15, that's what we're giving. But I would like Professor Schmidt and Mary to chime in on that as well.
Yeah, if I can jump in real quick, I think 10 to 15 is what I usually recommend for those 8-week accelerated online classes. And as Dr. Baldo said, I think it does depend on your background. If you have a really strong programming background, maybe one class is easier for you. If you really are good with Excel, maybe OR 531 will be easier for you, or it'll be more challenging. So there's some variation just depending on that. But 10 to 15 is really solid for all your classes except the capstone. And I'm sure Professor Schmidt was wanting to talk about that. We do generally say 25 hours for the capstone. That's the most intensive one. You're going to be taking it by itself. It's a team-based project. You're working for a real client, and it's your last one. It's like the culmination of everything else you've done. So it is more time intensive. And so we get students ready for that in advance. But normal classes, 10 to 15, a little bit of variation. And if you are finding that it is taking you substantially more time than that to get everything done, reach out to me. We talked about support from professors. If it's a more overarching thing and it's not specific to a certain course, and you need help with study skills or you're just struggling, you can meet with me too. So that's another interaction and support you can have as you're going through. But yeah, 10 to 15 is pretty good, except for the capstone. Professor
Professor
Schmidt?
Schmidt.
Yeah. So once again, when we look at the capstone, it really depends on the type of project that you're working with. We have some capstones which are traditional data analytics. You're given a nice security data set. You're asked to analyze and visualize the data, and those are the kinds of sort of things projects you would get in a regular course. But then, as I mentioned before, we are also dealing with bleeding edge and cutting edge technologies, and technologies that you're not going to be able to take a course for. And so the idea behind the capstone is that it mimics real world. I mean, if you go into industry, you're assigned to a project team. You don't get to choose who you work with. You're assigned to a project team. You're assigned the project you're given. So it's the same way in the capstone. And a good example is the 5 courses I was thinking about initially. Every one of those project teams is working with MCP servers. Now, MCP servers were developed by, I think, what was it, Anthropic, Dr. Baldo, less than a year ago. And like I said, there is no academic course, at least at Mason, and certainly not in our program, that teaches you about that. So what you wind up doing is having to spend a lot of time outside the classroom, on the project, researching these new technologies on your own. So that's why you can get 20 to 25 hours a week on some of these more challenging capstones, but at the same time, you're going to get exposed to new technologies that most other students don't get at in a typical capstone course. So it varies, but yeah, that's
Yeah.
good. Think of the capstone as like a part-time job.
Yeah. And the hours per week is really relevant because the online program's part-time only, and we do that because we have a lot of folks who have busy lives, they're working full-time, and we want to make sure that that coursework is something that's manageable, that you're absorbing, that you're getting everything you need out of, and that's kind of why we do recommend the course ordering and stuff that we do, so that you're able to fit that 10 to 15 hours and then eventually that capstone experience into your schedule and really be successful in it.
Okay, great, thank you. Regarding the admissions process, do you want me to talk about that super quickly?
Mhm.
Okay, perfect. So actually, so you need your transcripts. Unofficials will do as long as they show a degree conferral. And then once you're accepted, then we will need official transcripts, a copy of your resume. I do believe now there's 2 letters of reference that are required. Is that correct?
For the master's, yes. For the certificate, I don't think there's any letters of recommendation that are
Perfect.
required anymore.
Perfect. And then the personal statement. If you're not already working with an enrollment coordinator, such as myself, feel free to reach out and we would be happy to provide you with the application checklist, because there is like a guide for the personal statement. And yeah, it's pretty self-explanatory. I'm just going to go ahead and forward. You can scan this in case you're not speaking with anybody. So this is the number, the email, you can scan that if you're not speaking with an enrollment coordinator, and we'd be happy to help you. One wonderful thing too is that there are 3 starts a year. So fall, spring starts in January, despite the name, and then summer. So yep, and data is very hot. So
Yeah. And we did have 2 questions in the Q&A. Is it okay if I answer those real quick?
please.
Yeah, so one of the students was just asking, hey, is the application for spring still open? Yes, it is. I don't know if there's a separate deadline for the online program, but on campus it's December 15th. Susan, do you know if there's a separate one that y'all are still accepting?
It's okay. So the deadline is the same. When you start the
Okay.
application, it'll have you review the deadline. However, I really encourage you to apply as soon as possible. Here's why. The school is going to close for the holidays. So to give admissions sufficient time to look over your file. And it's done on a rolling admission. So the sooner you apply, the sooner you get a decision. So yeah.
Yeah.
And
It's never fun to do it last minute right after the university closed for several weeks. Everything's kind of slow. So the sooner the better. But yes, we still have time. And then also the other was, since it's an online course, is it possible to switch to in-person down the road? So if you are in the area and right now, for whatever reason, your schedule online program works best, but say in your last semester or you're a little bit further down the road, you do want to switch, that is possible. Just talk to me, and we can help you out with that. Usually we say one-time switches are what we try and stick with, not like flip-flopping. And it's usually because life circumstances have changed or something's gone on. So we're, like I said, flexible. That's the word, that's our keyword. We work our best in any way we can to help students. So yeah, just talk to me and we could talk about that.
so it's an amazing program. I can tell that y'all provide lots of support, and that's wonderful. One last question, because I know we're going over time. I've had students that are like, they don't have that 3.0. And so y'all do allow a GPA addendum, correct?
That is correct. I think before they do that, like make sure you reach out to Susan and discuss your situation, because Susan can reach out to Mary and discuss that in some more detail. But yes, it is not a hard, fast, it's not a line, and if you fall below, a micro inch below the line, that we're not going to look at you. We will look at you. So, but first talk to Susan, and again, if there's more questions or something, then Susan can bring in, talk with Mary and myself and Professor Schmidt as well if necessary. But yeah, please consider us. and we are here to make you successful.
Wonderful. Well, thank you so much for all this great information. And oops, I think we're done. I think we're good with the questions. Right, we got them, everything.
I think one last came in, but
Okay.
I'm going to put the program email address again in the chat, datamine@gmu.edu. Please follow up. I'll get back to you tomorrow if any questions I can't answer tonight, and we can chat, make appointments to talk a little bit more in depth one-on-one as well. Okay.
Thank you again for everybody, everything. And thank you, students, for joining us this evening.
Yeah, thanks, folks. Really looking forward to seeing your applications, and I really thank you for giving us an opportunity to describe and talk about the program and meet us.
Fantastic.
Very
Oh,
fun.
there's one more question. I saw the concentrations we could choose on GMU. Are
Mhm.
they available?
So we talked about this a little bit earlier. In the fully online program, there's a limited number of concentration electives. So most students do the individualized path of study where you don't pick one particular concentration. There are two that are possible, applied analytics and business analytics. So at the moment, those are the only two concentrations, full concentrations that are available in the online format. But often doing the individualized path of study allows you the most flexibility. And we can kind of chat about what is the perfect kind of mixture of those concentration electives to kind of get the most out of the degree for you. But yeah, just those two right now, but a lot of students love the individualized option.
Yeah, so I'd just like to add to what Mary said. The two concentrations that Mary noted, those are two of our most popular
Yeah.
concentrations on the on-campus program. So yeah, and as Mary said, we're trying our best to get some more programs on and maybe add another concentration.
And the other thing too is if you're local, you can start out online for that flexibility.
That's
And
right.
if you like a concentration that is on campus, you're allowed that one-time switch, right? So
100%. I have some students who'll do that. They'll take like heterogeneous data fusion and they'll be like, this is super cool. And I'm like, well, there's more of these predictive analytics courses if you're able to attend some of them in person. And so sometimes those can be good shifts and you can get the most out of all those modalities that are available to you.
perfect. Well, thank you again for staying extra and staying over and
Yeah.
answering all the great questions. And thanks again, everyone.